Can you see it yet?
Yeah, it's in the backstage. Let me add it to the front stage. Add the stage. Okay, we see it. I see the map on the right, reservoir size, distribution, and map.
Yeah, so this is hardly polished or anything like that. So, and to give you the backstory, I went this route because I'm very new to Dash, so I'm just kind of diving in, and I thought, give myself a challenge with callbacks, which turned out to be a real challenge. so sort of thing. But basically, the idea here was that I used a Dash leaflet map.
Nice.
With the clustering, so you can zoom in on any given map. Where's my favorite dam? Because I've actually visited it. It's over here somewhere. There we go. Grand Coulee in Washington State. And then the idea was there'd be a pop-up that would give you, summary information from the data set.
Oh, nice.
I was actually going to try, if I kept going with the project, I was going to try and make this, a little bit adaptable depending on, because there's a lot of, not applicable fields depending on where you are. So, or depending on what type of dam it is and stuff like that. So I was going to see if I could do something dynamic to kind of, give each dam its own little story. It's not clickable, but there's the website that's associated with it at the bottom if you want to go take a picture of the dam, stuff like that. So that worked pretty good. I ran into a little trouble at 90,000 data points. It's slow to load. So, and for a while, it was slow to even navigate. And I don't know what I did. Probably maybe it's the ordering of the calls or something, maybe more efficient or less efficient. I don't know enough yet about what I'm doing to really, and perhaps there is a, knowledge base there in terms of how you code callbacks.
But it was 90,000 dams? I thought the data set had like 10,000.
Oh, I went back to the data set, the main data set from and it's like about 90,000, right?
Oh, wow.
So,
okay.
Anyway, so my vision was that I would take, now I only did it for sort of dam reservoir size here. And the idea was that if you're going to explore the data, if you picked some sort of, data variable that was on some kind of continuum, I would just rank that continuum. In this case, I chose size and said, okay, if you're interested in filtering on size, you probably wanted to see the distribution of sizes. It's a log scale, but you can see that by far the majority of dams are under, a couple of hundred acre feet, right? And if you want, and so you could basically refilter the map based on the size range that you wanted to look at for dams.
David, 1 second, please. So I can't. Maybe it's just I can't see it well on the screen.
Oh, sure.
But the x-axis is representing what? The rank of every dam?
Yeah. So I just ranked every dam. I took one variable, in this case, the size of the reservoir, which is in acre feet, right? So it's a volume measurement. And I said, okay, I'm just going to rank the entire list from smallest value to largest value and put it on this scale. So if you adjust the sliders, you can say, well, if you only want to look at the biggest dams, you can just, max out to here, right?
I love this.
And when you update the map, it will just knock it down to those ones, right?
Oh, nice.
So for example, if I make the max and the min the same, right at the top, there's only one dam. If you look down here, wherever I go update, you find out those are the locks at that essentially hold back all of Lake Superior. So that's why they win.
That makes sense.
Right? So if that was if you were interested in dams by size, this is what you would do it. I didn't get to the point, but I was going to do it for anything else too. So for example, if you're interested in dams by depth of reservoir or height of the dam, you would be able to do the same thing here, and you basically have a rank, right? But I didn't quite get that far. But I don't think it shouldn't be possible to do. So, but it was a great learning experience, that's for sure. And I couldn't figure out the callback that would let me automatically update from adjusting the slider. Couldn't get that to work, so I had to put in the update button.
I love the slider.
Yeah, the slider's a good addition.
Very nice. You said you're just learning this stuff, David?
Yeah. So
that's it. Not
Yeah,
bad for
but
newbie.
apparently I have a little bit of OCD because once I got into this week, everything else. I mean, I didn't even empty the cat litter box for 3 days. Like it was.
Okay. No, it's really good. Regarding the filtering issue, um, I think Adam would agree. Like usually, like your big data frame is a global object, and then you do the filtering and a callback. Um, so there might be something in your code that does the filtering. If you're using pandas, there's many different ways to filter that have different levels of optimization. I do it all in polars, but that's clearly in the path of updating your graph every time following a callback change. But
Yeah,
Okay.
that's true, Mike. And then they make sure that when you update the data, you don't update the global data. Meaning, if you imported the data at the top, like a DF, when you're in the
Yeah.
callback, don't update DF. Make a copy of that.
So you're using a subset of DF, a new data frame. That's a filter of the global data frame, and then you go and call back again, and it makes a new one. But so it's
That you know what, that might actually have been it. That might actually be what I need to do because I think I was working straight from the original data frame.
Okay.
So
Yeah.
that's a good point. Like I should.
So David, what is this line telling? Is this line, if I can see correctly, this line is telling us there's a bunch that are rank 0 or close to like the first 1,000, where the acre feet is anywhere from 0 to like 50, right, or 90, something like that.
Right. So if I go down to here, and we just look at the left-hand side of the curve, you can see down here the minimum size is basically 0.
Yeah.
I mean, because it's a log value, I had to make sure that I cut out anything that wasn't true 0, right? And up to 14 acre feet, and that's the first 4,300 dams, basically. Right.
So also, what this is telling me that the great majority of dams, or am I reading this incorrectly, are between 14, 100 and something to like 10,000. That's the great majority.
Yeah.
That's where they sit.
So if I move the sliders to this way, then we sort of see the majority of dams are between 20 and 250.
20 to 250, like stitches. At least 2/3 of the dams.
Yeah,
between
and that's
20
like
and
60,000 of them are in that range, right?
Yeah, 2/3. Okay,
Kind of thing, right?
which makes sense. Not all dams are big, and all dams are very small. It's somewhere in between.
Yeah. And then so if that's what interests you, then those are the ones you can explore, with the update or whatever. But
wow, really nice. Very nice usage of the callback and this chart.
Mm-hmm.
How did you add those red lines? Do you remember in the code?
Yeah, so all of this is a Plotly Express graph.
Okay.
At heart or whatever. And to be honest, I was running out of time to get that to work. So I actually, used AI to kind of fill in a couple things and stuff like that. So I haven't gone back yet and really looked at it carefully so I understand how it did it or whatever.
Yeah.
Right.
That's often a good way to do. Oh, Mike, go ahead.
Just 2 vertical bars at the X coordinates where they belong.
Yeah.
I do that a lot manually. That's one line of code for each bar. It's really, really handy.
Yeah.
Cool.
So that's where I'm at.
Excellent. Hello, everyone.
Hey, Alex.
Hello, Alex.
Hey. Excellent.
Okay.
I like it. I like it. Your app. Beautiful.
Okay.
Beautiful.
All right.
So let's have a go.
Yeah, it really is beautiful. Like anybody who had a chance to use it would be, I think, compelled by just the way it's presented is really compelling. And someone else could do essentially the same thing you're doing and do it in a much less compelling manner by how they style the plots and everything. So you did a great job. It really knocks me off my chair that you're a beginner at this, but
David, you should post this on the forum. It's really good.
Yeah. Share the code, please.
Yeah.
Man.
All right, okay. So I'm a little embarrassed by the code. It looks really nasty. I'm not sure who everybody is here, but is Mike on the call?
Yeah.
I haven't
Mike's
had this me.
Yeah, so you posted something which looked beautiful, and I took a quick look at the code, and it's beautifully laid out. And so I'm actually I'm gonna, if you're okay, borrow your structure and go back.
Do whatever you want.
You have a nice
Absolutely.
division. You have very nice divisions of components and data section and everything else. I'm kind of all over the map. Like it's.
I've been on this forum for almost a year, and in the early days, I was embarrassed to post my code as well, but I usually spend a little bit of time at the end before I post it, just cleaning it up and cutting out all the dead code and making something I can support.
Yeah,
so
exactly.
it's a good practice in the real world too. I have some code at work that's absolutely dirty as can be, but you gotta clean that stuff up if anybody else is gonna understand it or read it. Do you use polars or pandas?
I just use pandas. I've heard of polars. It's supposed to be better for faster for larger data sets or something. Is that my understanding? Is that correct?
It generally does perform better on that and filtering.
Okay.
But I like it for its syntax, actually.
Oh, okay.
But
All right, Mike, do you want to show us what you have?
sure. This is like, I don't know how to describe this, but I'm like a rock band and the Beatles are opening up for me, but that was a good performance. All right, let me go ahead and share. I didn't get a chance to update this dashboard beyond what I posted earlier this week,
Okay.
but there we go. Let's see, percent share screen. Okay. Go.
Hi, Rishi.
Hi, how are you?
Welcome. All right, Mike.
Okay, do you see my screen?
Not yet. 1 second. Let me add it to the stage. Okay, we see it. Let's make it like a little bit bigger.
Yeah, okay. Let's go this way. So I'm really still on my learning curve for Dash Enterprise dashboards. And I think I made some progress this week with this work and hope to continue. I probably spent as much time just trying to implement the dashboard mechanics as I am in trying to beautify these graphs. So I expect better work in the coming weeks. But all I did was I created a pull down that chooses the state and draws basically a map of where the dams are located in the state. And so
Mike, do you mind making the size of the window a full complete size?
Yeah. Okay.
Okay, now we see it. Okay.
Okay. So anyway, back to the filtering topic. I just wanted to, I'm only including dams from the states that were selected. And so this gives you like a color coding of when the dams were built. Adam, you made a good comment about the dam building boom in California in the 50s and 60s. And
yeah,
there's a lot of truth to that. The state was growing in population, incredible growth. And we're a state with kind of a semi-arid European climate. In most of California, there's virtually no rain from May through September. So we pay a lot of attention to our dams out here and how full they are at the end of the rainy season and how much snowpack is in the mountains. So it's definitely a topic that hits near and dear to home. So I really enjoy doing maps with Plotly, and so that was one added fun element for this week. This is the first time I actually put a card on here with information for the data set. I thank Alex for the inspiration because he really does these things so well and so better than anybody. And so if I shrink this down a little bit, I put in basically a Pareto bar chart given the largest dams in the selected states. And you can see some of them are equal because some of the lakes have multiple dams on the same body of water. I sure could have taken this a little further. And then I dumped out a Dash AG table of data from the state. But I have a lot to go as far as getting all the good bells and whistles mastered for this. And I'm on track to do that.
What'd you learn,
And
Mike? What'd you learn from building this Dash app?
well, I got a card working. That was good. What else did I learn?
Maybe like
How
about
to,
the data set also. Is it clean? Do you think it's missing anything?
I think it's a pretty good data set. And one thing I look at when I judge these data sets is when you have multiple categories, and some of the categories have like millions of values, and some of them have like 1, 2, or 6 or whatever.
Yeah.
So in this case, I think there's overall, I would say level distribution in the states because the desert states have fewer dams than say Georgia, but overall it was a pretty good data set, and I think the number of values available for each state gave it some meaning. And you can go to like Guam where there's only one, you get 1 point on there, but still, there's a lot to work with. There's certainly a lot more I could have done in this. I just focused on the storage of each reservoir, but there's obviously so many other parameters. I want to do something where I take this hover data and maybe just show a card of that specific dam and give all of its stats. But I didn't get to do that, but hopefully I'll do more. And I saw this, Adam, in your video on the 6-part dash course, and one of the dashboards that Alex did is I think it's really cool when you click on a data point and use that hover information as a callback to produce a table or a card specific to that one point. Is something I want to go further on. So,
When you, Mike, and everybody here, this is a question for everybody. When you're working on a data set, what do you find more interesting, and what sucks you in more? The process through which you're learning about. You're thinking more about how the data should be visualized. What can you learn from the data? Insights from it, or you're thinking more about how do I build a Dash app, or you're enjoying more the building of the app and the building of the plotly graph?
That's a big question, but I love it all. But I'll just tell you that everybody has their own strength and less strength items, and I enjoy really cleaning the data and learning from it.
Okay.
And I like everything involved with Dash and Plotly. But the one limitation I feel personally is you get to a point where the skills you need are less about how good of a coder you are, and it's more about how your own artistic sense.
Yeah.
And that's something. It's hard to teach it, and I'm certainly not born with that. But that's an important thing. And the previous dashboard did that so well, much better than I'm doing here. But
thank you, Mike. Thanks for sharing. That's a good point. What else? Yeah.
Well, I learned how little I actually know about these Dash AG tables, but I want to do more with them and make sure I can get them to work the way I want them, and maybe use the table for a callback. So I want to get a little more involved in that. But generally speaking, the cleaning the data and doing your exploration is something I have that part down pretty well, and I've gotten pretty good at making these Plotly visualizations, but really organizing them into the dashboard that you really want, deciding what kind of buttons and filters on there is an area I want to focus on. But
what about, thank you, Mike. What about everyone else? Do you more enjoy the process of building coding, like building the Plotly graph in the Dash app, or you more enjoy the process of thinking about how the data will be visualized, how to tell your story?
Now, even before, I started with Googling the types of dams. And then I started to look at the data set and was thinking about, if it's high risk, how many times are they inspected?
Yep.
Are they in time? And the end step is actually, okay, well, have to put it on the screen.
Yeah,
Something like that.
I see. Okay. All right. Mike, thank you for showing us your app.
Thank you.
All right, let me move here back to the presentation. Where were we? Okay, let's move on to Marianne.
Okay.
Do you want me to share or do you want to share screen?
I think I want to share.
Okay.
Try to share. Wat knop is dat nog maar weer? Present. Dat was het. Share screen. Cafe. Okay. Can you see it?
I see. Wait, let me add it to the stage so everybody else can see it. Okay, we see it.
Okay, well, this is one where the exploration was far more interesting than at the time than putting it on the screen. But I wasn't certain about the periods for the inspection, if it was months, years, or a combination. And then I bumped into the emergency action plan. So I had a chat with ChatGPT to explain everything to me about this plan and when it's required or not. And well, the idea is that when the hazard potential classification is high, here, that's I had a complete data set of 90,000 dams.
90,000. Oh, you use it like David, the complete one. Okay.
Yeah. When the hazard potential classification is high, an emergency action plan is required. So what you see here is that, 76% have an emergency plan, but 24% have not. So for every classification, you can see the percentages. If the plan is in place, but when a high hazard potential classification means when something goes wrong with the dam, there could be death. A significant classification means something like flooding. When the dam breaks, roads can be flooded or whatever. So high impact still. But the emergency plan is not required, but suggested. So you can see it gets lower.
But Marianne, is that telling us like there's 11,320 dams with significant hazard potential? And if I go to the right, from those 11,000, it's telling me that 41% of them, let's say like 5,000, do require emergency plan, 23% not required, and 34, I'm not sure what the purple is.
No, what it says is 41% have an emergency action plan. 23.8 it's a no. They don't have an action plan. No, I'm saying it wrong. It's not required. And 34% they do not have an emergency action plan. But that doesn't actually tell us if it's not required.
Okay.
Or if it's not available.
Okay.
I think the most perfect situation would be that it's either there is a plan or it's not required.
Yeah, I agree.
Okay. Then I got, because ChatGPT said, it depends a bit on the owner if the action plan is in place. if it's federal or government or, not private, they more often have it. So what I did, when you click on high, you see here who owns the dams and the number. And when you look at federal, you see that almost 96% of the high classification potential have a plan. That's okay. But when you look at private ownership or not listed, no idea what that is, you see that's far less. And the dams, still have a significant risk or a high risk.
Oh wow, that's you caught on to an interesting concern there.
Yeah, that's how I understand it.
Yeah.
So,
well, it's concerning. Like you obviously want to have a plan, especially if it's high hazard risk, and if almost 50% or more than 50% don't have a plan, well, I'm not going to go anywhere close to that dam. Yeah,
that's why I said, well, I also did the purpose of the dam, which was also interesting. So if you look at irrigation, 99% with the high potential classification have a plan. That's good. Debris control is less of debris. How do you pronounce that? Well, but recreation, that's far less. Well, and what you actually see here is that I'm not capable of combining these factors together. Ownership and classification and EIP. So it's, it's a duplicate. Yeah, and there was a callback when you look at significant, you see less action plans. When you look at the owner and significant, you see federal is also less than when it's a high hazard potential. So this is where I got.
Thank you, Marianne. Folks, any feedback, any questions, comments for Marianne?
Oh, I really like it. It's and I like that you can click on them and have them update with the callbacks. That's really nice.
I would second that comment.
Yeah, well, I have a comment for David. When you look at the code, it's a mess. I published it.
I feel your pain.
So just publish.
Just publish. Yeah. Marianne, it's a unique way. What I like about this is it's a unique way of showing the data. Like I never thought about this. Okay, I thought about hazardous, how hazard potential classification that could show the hazard classification on a bar chart. But you go a step further. Say, okay, let's analyze all those that are high hazard or high hazard potential or low hazard, and you extract more data categorically out of those to learn more about them. So your data store here is very good. Nice one.
Thank you.
Very nice.
I mean, just another comment is that in the real world, if you made a dashboard like that and you're not a subject matter expert on USA dams, you would be consulting with various subject matter experts. And when we do these data sets on Figure Friday, I mean, it's very rarely the data set is your specific area of expertise, but I think everybody does a great job, even though, we're not the experts on these matters, but someday the data set will come that you know very, very well, and you're going to present it to others who don't know as well in a brilliant manner.
Yep, agree.
Given that fact, this is all really good work.
Oh, thank you.
All right. Thank you, Marianne. Rishi, let's pass it to you. Do you want to show us a graph or an app this week? or you're just
Yeah,
observing today?
I did make it. Sorry, I didn't post it. But yeah, I can share my screen if you want.
Yeah, definitely.
Okay, one sec. Let me try to get it. Yep.
Okay, it's loading. Give it a second. Oh wow, that is pretty. Okay, we
Oh,
see
yeah.
it.
Okay, so my approach to this was you have, like Adam said, you have latitude, you have longitude, pick it and just use the US map. So I was trying to play with few of the components of storing the information also. I'll talk about it later on. The whole idea is you can pick a state from here, for example, let's say Florida, and it will zoom in back to Florida, and then you can have your dams information right from here. And let's say that you want to look into M-6A. Let the dam name be M-6A, and then once you click it, it will take you to a different page, give you all the information the information is present. Uh, Now, when I was looking into this, I did find out that there are some missing data present. So my first approach was, how can I get this data? And one option is, well, yes, you can get to the website and then filter out again. So you are like navigating from one tab to a different tab and then to a third tab to get more information. So again, I was trying out to implement the information from ChatGPT, as in using ChatGPT APIs, just to get information which are like not present, like hydraulic height, structural height, or let's say any other information which is like NaN or null value, for example.
But
So
ChatGPT is not happy with the amount of money you're giving it.
yeah, so I have exceeded the limit which I had put, so I was trying to figure it out. So this was just one part of it. The other way around is you want to know more about dam filter. You can then get back to based on your on the height as well as and the state. So you can narrow it down. Let's just take Florida for example. Doesn't have that particular height. Okay, let's increase it a bit. Hmm. Yeah, so let's say that you have this particular dam. So it's highlighted, and then you can click back, and then you're back to the tab details, and you can again check into the details. So the whole idea was to populate the rows as well as information about a particular dam, which is not visible. So I was trying to play with tabs particularly, as well as how I can hide a tab if I have not selected a dam, for example. So just playing around how to visualize the data.
Very nice, Rishi. I like the idea of in the second tab having ChatGPT or whatever AI quad filling the missing blank. But so if this would have worked successfully, this ChatGPT, and you had tokens, what would it have looked like? The supplement information would be down below, or would it
Yeah.
automatically plug into the card?
So the idea was to first show the missing data
Okay.
and then add it like, hey, this is data from an AI, verify it before you start using it. So that would be an highlighted text also.
That's interesting. We can have AI, and somebody clicks on this tab, you can maybe so it doesn't like automatically initiate every time somebody goes on this tab, so as not to use so many tokens. You can just have a
Yeah.
button underneath that says fill the missing data with AI or whatever.
Yes.
But they click it,
Yes.
and then it runs ChatGPT. It knows automatically what's the missing data because you can give it from the Dash app. And yeah, a lot of ChatGPT and now Claude has this capability to search the web, right, with Tavili and other libraries, and it searches the web specifically for that missing data, and then it just spits it out as a message, which is pretty cool.
Yeah, and then store it as a supplement data that tomorrow if someone pulls back for that particular dam, let's say M-6A, you get more details for that particular dam.
Very good usage of a large language model here. That's smart.
Yep. Majorly, I was trying to play with.
Yeah,
sorry.
Alex?
So, great idea, Richie. Let me tell you something. Maybe this use of ChatGPT instead of setting in a tab apart, you can take it. No, it's a suggestion. When you click on the map, maybe a window, open a window or a modal or something like that,
Oh.
and in the same page, that is the map instead of the other one. To user friendly, no, is the people like an alert. Here is the missing information that is not in for instance, is possible, of course.
Okay, thank you.
Any other comments or feedback for Rishi? How things can improve even more, or would you have done anything differently?
Rishi, I have a question. Are you using the smaller data set, or others have mentioned the 90,000 entries? That's the one I used as well. It's in that file nations.csv.
I use the smaller one.
The smaller, okay. And I want to ask you about this map here. The clusters caught my attention. Like, for example, New Hampshire is all filled, but New York and Vermont look empty. I'm not sure what to make of that.
My approach was just pick the latitude, longitude, and just fit it on the map.
Oh, so it's just Mike. So it's just missing data. The data, because it's using the smaller data set that I provided, it doesn't have all the New York ones. Yeah,
it's like all these states in the Northeast have a pretty, I mean, to my eye, it's a pretty consistent density of dams. And where this low density up in the Northeast here on this map is similar to Arizona or, Idaho and places like that, but it's not what I see in the data, but it's probably the smaller set.
Yeah, I was also trying to experiment with the rivers, lakes, as well as water bodies in and around. So the things I found out that the Plotly map part provides you the base, and then you can have different maps layer over it, and then use the latitude, longitude to show based on the water bodies also.
And this is a beautiful display. This is a beautiful display. No question about that.
I like it. If you change, can you choose California for a second?
Sure.
Okay, nice. And then you can click on one of the dams.
Yep.
Okay. There you go. Forgot how it was displayed. That's kind of cool. Nice.
This function is really, really, really cool.
And the website. This is plenty of information. So these are tabs, right? It's not a multi-page app. It's just a tab.
Yeah, it's just tabs. And also, let's say you can't click on tab details without selecting a tab. So something I was trying to play around was you can either pick using tab filter or based on the tab map, but you can't just go right away and start clicking into the tab detail.
That's interesting.
One suggestion I would have on something like this is that when you click on the middle tab and it brings up the card with information about a specific dam, I would somehow want to keep that on the same display with the map visible at the same time. Okay. Because an end user may want to, like, say, make a screenshot of a dam that's located someplace and show its stats. But
Sure.
Alex does that all the time, very, very well. He's the master of cards.
Yeah, true.
I completely agree with that, Mike. I was going to suggest, if you did not want to do tabs, one cool way to do this, Rishi, is to open up a modal. Right, you click on a dam, and it'll just open up a modal on the same page. So you're not moving the user to a different tab because you don't have too much information. You just have a summary card. And then you can definitely put the ChatGPT in the model as well in the bottom part of the model.
Okay.
And then obviously if you try it, if it looks too much in one modal, then you can always create a tab. But keeping the user on one page is often a good thing.
Okay.
Unless there's a lot of information and then a tab is justifiable. Now in your case, Rishi, usually people will not usually on website, doesn't mean it's wrong. It could be unique. It could be the new way of doing things, but usually tabs are clickable. And so if they're not clickable because you have to do one thing first and then the other, giving them the impression of the tab of a tab, because this is what it looks like and this is what it is, might confuse people, or other than won't be used to it. Again, it's not wrong, but if I go to a website, 90% of people are going to a website and see tabs, they're going to want to click on the tabs and see something. And it's like, oh shoot, this tab is broken because it's not showing me anything. Oh, it's not broken. Rishi just was planning to show like a sequence. So for that, Dash Mantan has something very cool. What was it called? I can't remember the name of it, where you can see like the sequence of things. And that's, I'll find it and I'll post it here. I think it's called Progress. No, that's something else. A stepper. So look at this. Let me share this link with you here in the comment section. If you go to the comment section of this StreamYard, click on that, and since you're sharing screen, maybe you can open it.
Sure.
You open?
I'm just looking at the comment section. Are you
not in the private chat, in the comments?
In the comments. Okay. Let me see.
Let me put it in the private chat as well. Here you go. In private chat, it'll be easier to click.
Yeah, daar is die.
So that could be something that would, first step, you wouldn't call it first step. You say click, click state, or click. The second step would be damn info, and it will automatically. I don't know if it's possible here because maybe it's with the buttons, but you see what I mean. This is more like what you're referring to with the steps.
Okay. Yeah, this is good.
Cool. Appreciate. Thank you. Appreciate it. Really nice.
Thank you so much. Yeah.
Love the styling of it. Background color with the neon colors that are really highlighted. They stick out. Okay. All right, Alex, let's go with you.
You have time. You have time?
Yeah, we have a few minutes. Let me see what let me share. I think I have it on your screen. I can share the screen, okay? I already loaded it.
I share the screen. It's very quickly. It's not going to take too much time.
Share the screen.
I'm not going to take too much time.
Pi Cafe. Okay, here we go.
Here we go. Well, basically here, this time I would like to focus on distinct US DAM. What is distinct US DAM? Because the unique, I wanted to use a machine learning model or algorithm. In this case, is isolation forest, and it basically it's why I decided to use it. It all as you all talk about was basically after a lot of when I see all the data, I make a lot of exploration and try to I made exploration with using numerical, categorical, etc. And at the end of the day, I decided to use isolation forest. Isolation forest is basically it's the opposite to random forest. The algorithm look for these dams in this case that have features, unique features or characteristics. This is isolated, and in this case, well, I prepare all the data. I didn't share because it's too long the code. Yeah. If anyone want to understand, well, I can share with you. Well, basically, what I did was build with this model 2 columns. One is anomaly. You can share Aaron if you want California, for instance, an state or whatever you want. California. Well, the idea here is to show using the cluster that comes with the data, that is the hazard potential classification, shows the state, every state, and see what are the unique or distinct dumps based on compared to the rest of the dumps in this hazard potential classification. If you click on whatever you want, for instance, here Patterson is basically here is the classification, the hard classification, significant, and I like it. I wanted to highlight with a radar how is this specific dump that was selected by the model as a unique is compared against the average of the other dump in this specific hazard classification. And basically is what I tried to do it. I did, in fact. And if you hover on the point, the Patterson, you will have the point.
Where, Alex? What point?
The red point here in the map. Okay, you see the name Patterson. No, the selected one.
Yeah, I'm trying. Oh, there we go.
Patterson. This information is complemented with this other information. Basically, the owner type, the completed. This was I tried to complement the data, the information, in order that the people have an idea. And basically that's it. The anomaly score is a measure that the model have to compare basically all the dumps in this case, and then to select what the dump is based on or maybe the filtering. If you see the here, I don't have it, but it's what is an anomaly or not anomaly. This is the way the model select that these are those metrics or those columns that I did in the model. And basically it's anomaly score that may be unique score in this case. If you can make another to speak more differently, and is the anomaly. And basically this was all I did. If you can look at here, for instance, Patterson, you will see that the difference clearly. For instance, illustrate all the difference in all the features against the average, for instance.
So you can see that the average is in red, and it's a lot more.
Yeah.
It's almost like,
exactly. And the average, that is the why, how the model classified as unique, right? And what is why is I like it to use it this way? Because there is smaller data set, 530 in this case. You can adjust it if you want to be smaller, and made an special, I don't know, digging in these unique dumps. And that's it, basically what I did. What I like it to do in this case, use this amazing data set to use this model, use this machine learning algorithm.
So everything, the machine learning, everything is happening under the hood, right? Behind the scenes. We can't see it. Yeah.
Yeah. In this case, no, because I use a column. As a column, I did it, and if you wanted, I can share the whole column where the magic is a function, where all the magic, let's say in that way, happens. But it's basically number, compare against each other, the feature, and to compare and see what are in average different from the others, from the whole the whole data. And also, obviously, in this case, I focused on was in hazard classification. For instance, the model is the unique is hazard. In this case, I look for different or unique dams inside this classification, hazard classification, using hazard classification like a cluster, like a natural clusters. Instead of I run or make another machine learning cluster, for instance. Here, yeah, I have it. I use it.
Now, I'm going to share here in the comment section what Alex shared with me on with everybody on LinkedIn. Oh, why is it
LinkedIn
separate posts? It comes up in separate posts. I'll share it also in a long private section. In the chat, you'll see you can copy paste this and read more about it. But he gave a nice explanation of how the anomaly was calculated.
Anomaly score, yes. Anomaly score. After the anomaly score, the model, you made a prediction. And the prediction is anomaly or not. This is a point. And you give all this number and the model predict. Based on this prediction, I have this data frame. The prediction mainly is a flag, and I give you -1 or 1. I map to 0, 1, and to select this like a boolean, and then I use these anomalies, let's say in that way. But in this case, not an anomaly. Is this what I refer? These are like the dam that are unique. In this way, unique, and basically they are unique because, for instance, in this case, Adam selected San Antonio. Look at the NID storage, the dam length, all the differences that you can see. Basically, using the radar against the average in this segment is what it basically did. And also, sorry. Yeah, finish with this. And also, I added that download filter data. That when you do this, the download filter data, you will see the whole. If you in a CSV file, but you will see all the exactly measure of this. Not that like this, if not exactly all the characteristics of this. Maybe next time, maybe a PDF or And that's it. Sorry, if I take time.
Such a unique way of seeing the data as well. Anybody has? We only have about 2 minutes. Anybody has any questions or feedback for Alex?
Great job, Alex.
Thank you.
I played with your dashboard earlier this week. I really love it.
Thank you.
Rishi gives a thumbs up. Yeah, Alex, it's. I like the angle of the data insight, how you decided to use, in this case, machine learning, pretty advanced stuff, to try and detect anomalies. Because there was no way, it was very hard for the human eye, just looking over the CSV sheet, to detect anomalies. Like I wouldn't be able to San Antonio. I'd have to look, wait, what's the average? I'll have to look at everybody together. Is this seems a little bit, maybe I could see, okay, the NID high seems a bit odd, seems a bit a lot higher than the regular the other ones I saw, but you're analyzing everything, all the data sets, and through that describing or defining anomaly, which is very helpful. Very helpful, Alex.
That the idea, you say something that is clear. If you don't, well, one thing is the technical points that I can understand, but the other challenge is the communication. And is the idea of connecting those two charts and to that the people clearly, or anyone can clearly see the differences.
Yeah, very well done. And I think the code, it's always here. If you go into editor, if people want to learn from the code, just go to the editor part. You can make this bigger. If you want to see the whole app, I'll go to the editor. and you can see all the code that Alex used. There's a bunch of code here.
Lately, I'm going to share with the other part of the code where are the machine learning in the function that
cool.
is helpful. It's very helpful.
Awesome. All right, everybody. Well, thank you, Alex. Thank you for presenting.
Appreciate it. Thank you, everyone.
Thank you, everyone. I'll release the next data set in a couple of hours, and let's talk about it throughout the week. Let's see how it goes. Provide each other feedback. Don't wait until Friday to provide each other feedback. Definitely post during the week. These are really cool things that we're learning from each other, so continue doing that. David, you got to post your code. We want to see that messy code of yours. That's it, everyone. All right. Well, have a good weekend.
Okay. All the best. Thank you. It was great.
Thank you. Bye-bye.
Have a nice weekend for everyone. Bye-bye.
You too. Bye-bye.